So, hello everyone to the final talk of this term's offensive security course. Most of you will know me already, but for the ones who don't know who I am, my name is Carsten Tellmann. I work for GData, and that's a local antivirus software company, and we are supporting this course. And besides the fact that we are able to invite quite good speakers, we offer an additional evening event at my company. Here you can see the dates, and yeah, basically it is about just sitting together, drinking, eating, and hopefully have nice and interesting discussions. So if you're interested in joining us, if you want to ask some detailed questions about the talk or want to get in touch with people working in the antivirus environment, then yeah, all of you feel invited. If you have questions, don't hesitate to come to me after the talk. And yeah, now I would say we can start.
Thank you. So this talk is about web application exploits, the payloads to do with those exploits actually. And it's based on my experience as a penetration tester, building tools while working during the job. A bit of an introduction about me. I'm a freelance pen tester. That's enable security is kind of me. And I've written some papers, published some tools in the voice over IP area. So Subvicious is used a lot for attacking voice over IP phone systems. And Webapp is a commercial set of tools and some exploits which work with Canvas, Immunity Canvas, which is a penetration testing framework tool set of exploits. And then there are some web application tools, as web application security tools as well, like WebWoof and ServeCheck. WebWoof is a tool for detecting web application firewalls, and ServeCheck is a tool for demonstrating the security issue when you have the cookie which is not set as secure. It's a tool that allows you to leak out the cookie. There weren't any tools back then to demonstrate that problem, so yeah, that was quite useful. So let's look at what my plan is for the next few minutes. Of course, I'll introduce the sort of problems that I came across while I was doing my penetration tests. Of course, I find out that not everything is as easy as pressing double click on some executable and things go well. So you have to write your own code, you have to make examples, and I'll explain that better. And then I'll give some proper examples. I have some sort of stories based on my experience. And then we'll look at what's in common across these stories. So each of these stories, of course, have something in common, and I'll introduce a new sort of tool. And of course, we have to talk about solutions. But this presentation is more about attacks, or more about your needs as a penetration tester rather than the solutions that you would provide to the developers. So as a penetration tester, your job is most of the times three things. You have to find security issues, and sometimes some penetration testers try to find as many security issues as they can, so they run a lot of tools and they try a lot of things. But you're also supposed to demonstrate the vulnerability, and sometimes you also have to help fix the security issues that you found. I'm gonna be focusing on the second one, because finding security bugs, security issues, there are some security bugs that are not so easy to find, but a lot of the process that involved in finding security issues is mostly understood. Don't get me wrong, I mean, it's very interesting to create new ways to find security flaws, but when it comes to cross-site scripting and so on, the basics, we know them very well, and it's very easy to find certain cross-site scripting vulnerabilities, SQL injection, and so on. Certain issues, certain vulnerabilities, you find them passively by just watching the HTTP traffic that the web browser is sending. So cross-site request forgery, for example, most of the times you just look at the HTTP traffic and you notice that there is no CSRF token, so it's vulnerable. Same thing with the cross-domain policy. When it's too permissive, the Flash cross-domain policy, then it's so, I mean, the web browser sends a request automatically most of the times to crossdomain.xml, and you can see what it's receiving. So it doesn't require a lot of work. And many penetration testers just stop there and do the bare minimum to show how to show the sort of vulnerability that they found to their clients. And kind of, I understand that, because if you found 20 security issues in one web application in 3 days, in the end of the time, you don't really have time to develop a demonstration for each security issue that you found. You usually have very tight deadlines. We were speaking before, and he mentioned that you get pen testers who do 3 pen tests in a week, and that's crazy. You cannot do that. I have friends, and they do 2 pen tests or in a week, and it's a lot of stress, and it's very hard to demonstrate any security issue. To find security issues, yeah, it's doable, but demonstrating them might be a problem. But if you want your client to understand you as a penetration tester, to understand how bad the security problems are, then you have to demonstrate how bad they are. Otherwise, they're gonna just put them in a list of bugs, and the developers are gonna look at them and prioritize them according to what they think they should prioritize them. And if they wouldn't like to fix your bugs because it doesn't look so interesting, then they're gonna work on their feature list first, and then maybe down the line. So as a penetration tester, it's very likely that if you don't demonstrate how bad things can be, you go next year, do the same penetration test, and you find the same problems again and again. And that sucks. You really don't want to do that. You want to find new bugs and make your job as interesting as possible and get paid in the meantime. So it allows you to justify yourself as a penetration test and make it worth it if you are able to demonstrate these security issues. But like I said, we have limited time, so it would be great if you have something which is kind of ready-made, which you could modify and have it working. If for your next cross-site scripting demo, maybe you don't want to show an alert pop-up, you want to show something that works. It would be good if you could reuse maybe previous code. And lots of course, everyone from developers to penetration testers, they reuse their own code again and again. So I thought it might be a good idea to share this sort of code and have it out there. So if your report looks anything like this, say you have a company called PayPal in this case, and you have an alert box right after talking about impact. I don't think it really displays, it really gives the message across, puts your message across, showing an alert box. What can you do? Well, if PayPal has this sort of vulnerability, it usually means, since PayPal, yeah, it's hard to pronounce it correctly or incorrectly. Have a cross-site scripting in this case, since they deal with credit cards and payments, then you want to show that as an attacker, this gives you access to perform payments which are not supposed to be done. So it's much better to show that, of course, but an alert box just doesn't show this. So I think the report should look a bit more like, not this one, but a bit more like this, where you can show that, for example, in this case, I show that I gained shell access to the system. If you gain access to credit card details, then put a nice big fat screenshot of their credit cards. Maybe mask them if you'd like, but passwords are pretty effective, especially the CEO's password might get people to change their password at least and fix the problems, I hope. So demonstrating impact, that's what we're talking about here. I think it's very important. So let's start with the first example. Passwords, they are kind of the #1 security feature of all web applications out there, most of them anyway. But they are, of course, as we know, the #1 weakness as well in many cases, especially when you allow end users to choose their own passwords. So a bit of background. It was a company that had a public blog, and on this blog, everyone from inside the company, I mean people from different departments, from their research team and their development and product development team, they could post on this blog as part of their marketing. So they would say how cool this new feature is gonna be and so on. And this is quite common nowadays. Most companies have blogs and they use them for marketing purposes. And for me as a penetration tester, what this meant was that there were various usernames which I could try to break into. And I gained access to at least one account. It had a very weak password, something like password 1, you know. Okay, P was capital letters, but yeah, it didn't take much time and I didn't have to do much effort. However, it was not as cool as it sounds, because the access that I had was I had an author user, so I didn't have a lot of access in this case. And I tried some privilege escalation tricks. I tried to find out what public security issues there were, but I couldn't find anything, and it didn't look so good for me. It was gonna be a very boring penetration test, I thought at that point. It looked a bit like this. I don't know if you guys can see this from, oh, you have your own screen. That's pretty neat. So I guess you can see that it's pretty limited compared to what an administrator could do, a WordPress administrator could do. So you can post a blog post and so on, but I was getting paid for this job, so I didn't really want to get embarrass my client, you know. So I didn't do that, of course. As an author, you cannot inject JavaScript through your blog posts. And yeah, it's very limited. So let's look at, they have various types of accounts, and I was in the middle lower band. I had author permissions. So, however, you can upload media and you can upload images and so on. This feature is for uploading images and then adding them to your blog post. And I tried to upload, of course, PHP scripts, but I mean, it was running the latest version of WordPress, not some WordPress from 2005. So kind of, you know, it didn't work. I tried other tricks, null characters and so on. They don't work. Not in this case anyway. However, and I found out that they use a whitelist of file types, images, of course, but they also allow by default HTML files, which was an interesting thing for me. And of course, there were other file types like SWF, exe. It gives you that sort of thing. This wasn't a Windows system, so I couldn't upload my exe and run server-side code as a CGI. So I decided to stick to HTML, even though the other file types are pretty interesting as well. So with HTML, it's like having, by uploading HTML files on the blog, it's like having stored cross-site scripting, right? Because, of course, I mean, you're uploading an HTML file that is being stored on their web server, on their domain, and that's great. So my idea was, let's upload this HTML file and then get the administrator to click on my link, visit this HTML file on their own blog, and then force the administrator to create a new user for me, a new admin user. So the way that I went building my payload was I installed I have my VM, of course. As a pen tester, it's always good to have some VMs where you can test, especially if it's a public web application like WordPress. It's good to have your own copy and then reproduce things as you go along. And started going through the. By the way, if you guys have any questions, feel free to ask. So first thing you notice is no leaking of the cookie. The cookie is set as HTTP only, so you cannot read it from JavaScript. That would have made my job much easier, of course. But and WordPress, of course, has CSRF token for quite a while. Has protection against that. So yeah, the idea when you have a cross-site request forgery token, if it's a public web application, then you know how the HTTP requests are gonna look. So you just have to grab the CSRF token, which is usually stored also in the session, and then replay the create new user command post request. With WordPress, it is like that, but it's a bit more complicated. So I started learning about their token generation, their WP nonce. Did any one of you look at WordPress and how they do their token generation? So I'll go through this. Basically, they don't store it in the session. So they generate a token for which works for that request, and I'm going to explain how that works. But they check it every time not against the session, but against some logic. So they have some logic, which sounded quite interesting for me. After looking at the code, you realize it's relying on time, the page or action, actually. So every action would have a different CSRF token, and every time would create a different CSRF token as well. The user ID and the secret. Until I realized that there's the secret, I was thinking, oh, that's great, we have some 0 day here, but the secret is, and then when I realized that we have the secret, I thought, oh, we can do MD5 brute forcing. But it's quite long and it doesn't seem to be vulnerable. Maybe someone can take a better look at it and find some security issue there, but no 0 days for today, sorry. But I did realize, this helped me realize that I have to first get the correct CSRF token. So since each action, say, create new blog post, that's an action. That would have a different CSRF token than the action for creating a new administrator user, which complicates things a bit, but not too much. Not too much, especially if you're using something like jQuery. How many of you have used jQuery in your, yeah. I mean, many web developers are using jQuery all the time or some other framework, and it makes things easier and your code cleaner, and I guess it works across different browsers. It's more likely to work across different browsers and versions, not necessarily true. So the code ended up looking like this. So first, this is the victim's web browser, of course, in this stored cross-site scripting or HTML uploaded file. So first, the browser sends a GET request. The browser of the administrator sends a GET request to the user new page, which is a PHP file in /wp-admin. And then from the data retrieved, the browser reads that data and searches for the value of WP-nonce create user. It also gets the referrer from there, which is another field, and then generates the other stuff like password, username, and sets the privileges of the role of the new user as administrator, and sends a post request using the web browser of the victim again, which is logged in, of course. So let's do a demo of this. So this is the victim's machine, and the victim is logged in as an administrator. And I'm just going to show that there are only 3 users, and the attacker is some author, and the logged in user, the victim, is admin. And then we have the virtual machine. This is the virtual machine of the attacker. And the attacker has guessed the password of the author user. Logs in. Goes to media, add new media. And then in this case, I kept them separate. I had index.html, which calls jQuery, and also calls new admin.js. And you got the path where it's been uploaded. Of course, it's uploaded according to the date. As a pen tester, it's good to check that your code is working, of course. And then in this example, I use Skype. So you need some sort of social engineering attack, but most of the times in a realistic attack, you would use email or something like that, but it might be more targeted as well. So the admin victim opened the HTML page, and you can see that the new user has been created in the background without much interaction. Okay, you need social engineering, of course, but and then as a pen tester, you don't want to stop there. You want to exploit the sort of access that you have. So it's a good idea to show that gaining access to the blog doesn't mean just gaining access to the blog, but also gaining access to their server and their database and their all their passwords, at least the ones that you can crack, and so on. And that starts something like by doing something like this, uploading your own plugin, because plugins in WordPress are written in PHP, so it's server-side code. And yeah, you don't need to be logged in anymore in this case. You just have to access your new plugin. The path is something like WP content/plugins, something like that. So in this case, the plugin just gives you shell access. It's a very simple plugin, but I think it demonstrates that you have access to their servers. And as a pen tester, then, depending on what they have on their servers, it's quite often that they have other websites and they might have more interesting data, or they have the same credentials on the database server, and it's being used by some other web application that has a customer list, for example. Stuff like that. So that from having just an author account, if I stopped there, then I would have moved on to the next vulnerability, of course. But if I stopped there, then I wouldn't have found out that this can lead to much more interesting stuff. Now let's look at a similar example, also involving WordPress. WordPress was quite comfortable for me for these demos, but same thing applies for other web applications. So you have a WordPress installation, and it has no known public exploits, and in this case, no weak passwords, so I cannot log in through their WP admin. But on the same domain, there are other web applications. So this is something that I come across quite often. You have a reverse proxy. So the same site, you see www.example.com and /blog would in the background go to a web server which handles PHP files, PHP scripts, and has MySQL on it maybe. And /carriers has a static website, just HTML. And it's going to a separate server. It's considered secure. No vulnerabilities there, at least not server side. However, in this case, /carriers, there's a DOM-based cross-site scripting or a vulnerability, or a client-side cross-site scripting vulnerability. But my client thinks, since it's a static HTML page, what could go wrong there? That's quite common. They think about the server side only, but this kind of is great for proving your point that all web applications should be tested on all the domain that you're supposed to test. At least you should give them a look, especially if it's a very large site, like Microsoft.com, for example. They have so many different directories and so on, which one of them, if it has a cross-site scripting vulnerability, might be a security hole for the whole domain. So in this case, the code looked like this. What it's doing is it's creating an iframe, and the iframe is based on user input in the URL, and this is all client side. And the src for the iframe is taken after the hash sign in the URL. So you get something like this. But I was saying that a few minutes ago that it's quite a bad idea to show this to your clients. And yeah, if I show this to my clients, then they're gonna tell me, yeah, but it's static and there's nothing on this site. It's all public information anyway. So I made a demo here. You have the blog on the same site where you have the carrier's site. So in this case, the site is called Webapp Demo, and /carriers has the client-side DOM-based cross-site scripting vulnerability. And then you have the WordPress installation. Again, the administrator is logged in. And while logged in, the administrator likes to browse other websites. Like his competitor's careers page, maybe. So as soon as the victim administrator clicks on this link, it redirects to the administrator's website that has the cross-site scripting vulnerability. And it's using the same payload as before, but in a different exploit, in a different vulnerability. And once, as a logged-in administrator, you refresh, then you can see that there's a new user created there. It's been running the same code as before, but just on a totally separate web application or website, static HTML, that happens to be on the same domain. So enough with WordPress for now, and I'll go through a different scenario. I guess we all know some developer, and they can all tell their stories of dealing with different technologies. Adobe Flash would be probably one of them. If you know any Flex developers, then yeah, they might look like something like this at some point. And for this demonstration, I decided to take a screenshot of a real website. So I went to some online casinos, and just the second one I think that I tried had what I wanted. So it doesn't take very long to find crossdomain.xml, which is wide open to attack. And I'm going to explain how to show this vulnerability and convince your clients, if you're doing a pen test and you find this, how to convince them to try to solve this at least. So online casinos. I come from Malta, so we have good legislation for online casinos and all these gambling sites. And I do have clients who are in this industry, and they love things that flash, and there's nothing more flashy than Adobe Flash. it's great. Even the name sounds very nice for online casinos. And also nice for them, also ideal for them, is that Adobe Flash on the client side allows you to access content from different domains. It's a feature of Adobe Flash and some other technologies like Silverlight as well. So you might have, if you're a developer and you're working on for an online gaming company, then you might have your SWF files on your servers or your content delivery network in the cloud, wherever it may be. And then you would have the logic for the game on some other server. Maybe it's a third-party operator on a different domain name and everything. And then you might have your logic on your own server for login system. So these are all, and there's probably more in the background. These are all things that you want to integrate and call from your SWF file if you're a Flash developer. And if you don't do this right, then it's very likely that the developer starts hitting major problems. Maybe when he's developing, he's running everything on localhost, so everything works fine. He does all these cool things across domains, all on localhost. But once they go live, things start not working and they get lots of errors. At which point, I think the developer would look something like this, not very happy, until he starts Googling about and finds a nice post on Stack Overflow, where you get all the security answers. And I looked up on Stack Overflow, and you find lots of problems with these sort of issues, and the answers tend to be, use this piece of code, put it on your web server, use this XML file, and everything, and all your problems are really solved, except for the security problems which you just created. So it's a bit of a black or white sort of solution. And I guess you guys are familiar with this, but I'll just repeat it. What this says is that if a victim who is logged in on your own online casino browses some other site, and this other site causes Flash to make HTTP requests, then this other side, the attacker side, can perform these HTTP requests and also read the responses, which means that it can do actions on behalf of the victim who is logged into your online casino and maybe play his money or whatever, his credits, change passwords, change email addresses. So I thought, it's great to demonstrate, especially for my online casinos, for my clients. It's great to demonstrate this sort of vulnerability. And I started looking about, and I didn't find a lot of good examples. There were various blog posts listing websites that have this sort of vulnerability. I think in 2006, at least, there were people picking on adobe.com itself because it had crossdomain.xml, which was with an asterisk. And they were listing other sites. But I didn't find a lot of code which shows you as a programmer or as a penetration tester how to abuse this problem properly, easily, ready-made code. And most penetration testers, maybe they don't have experience with Flash. And in just 3 days that are left after finding this vulnerability, if you have a deadline, you won't be learning any Flash during that deadline. So it would be great to have a lot of more examples. And I think malaria is a great project. Has anyone heard of the malaria project? It allows you to exploit this sort of vulnerability in Flash when you have cross-domain.xml, which is too permissive, and also Silverlight. And it allows you to make use of the web browser of the victim as a proxy and make your HTTP requests through that proxy. It wasn't so good for me because I didn't know when my victims would be browsing the website, so I didn't want to have malaria open all the time. So I settled with another piece of code from a different website, which allows you to interact, to make use of an SWF file, and you can control it through JavaScript. So we have the attacker, and the attacker has noticed, in this case, cross-domain.xml, it's too permissive. So the attacker has prepared a web application, a Flash demo with this code that I mentioned, which creates a new user. Same thing as before on WordPress, but this time using Flash. Again, the attacker tells the admin, click on this link, please. And since he's asking very nicely, the admin just clicks on it, even though it looks like a malicious link to me, and it's doing stuff in the background. And we have the new user again. And this is doing the same thing as before, but this time by making use of Adobe Flash. So the way that works is it's doing the same things, but by making use of Flash. However, the web browser of the victim first checks cross-domain.xml of the vulnerable website, and as soon as it sees that there's a match, that the attacker's website is allowed, because asterisk allows the attacker website to perform these actions, it runs these HTTP requests. So you have the GET request there, as similar to before, and the POST request. Now the new code, the new demo code, is now making use of the same JavaScript as before, because there is a plugin for jQuery. So you can just reuse, with the new version, you can just reuse all the payloads that I created with JavaScript. You can just put 2 lines at the start, and they start working with Flash as well, which makes things much more simple. A different example. In this case, has anyone heard about blind cross-site scripting? Did you? Okay. This I think there was a presentation at DEF CON this year about blind cross-site scripting. And there were some other people who posted on their blog about blind cross-site scripting, but it's relatively new from a publishing point of view. But I guess other pen testers have been doing it for a while. I've been doing it for a while. But let me explain what the background is. in many cases, when I do a penetration test for a web application, I try to test both the customer web-facing website. So if it's, let's go back to the online casino. If it's an online casino, you would want to test their casino stuff and their user when you create a new user, registration and so on. But I also like to test the back office, which is where you have support people dealing with emails and complaining about not getting their money in time and so on. Because I think the back office is where where a lot of things that are valuable are. In the back office, you can often see credit card data, maybe masked, but it's still kind of a problem. You might see passwords or allow you to reset passwords, at least in many cases. So it gives you a lot of power, and if it's an online bank, it allows for fraud. If it's an online casino, it allows for fraud as well. So it's quite a problem if you have security issues there. However, sometimes a lot of clients allow me to test the back office. But from time to time, I have new clients, and they kind of, I guess, I made some reference to Fight Club. They wouldn't like me to test it. They tell me, look, it's out of scope, don't even mention it. And tell me then, even if I tell them, hey, it's where all your sensitive information is, wouldn't you like me to find out if that sensitive information can be leaked out? And then they just say, okay, isn't your approach, isn't a penetration test a simulation of a hacker attack? And yeah, you're right. So that's my job, right? And my job is to test their site, which is in scope, which is the customer-facing site. But sometimes it might also lead to access to another site that I might not know about. And that's what blind cross-site scripting is about. It's about injecting your HTML and the JavaScript on a site where you're not familiar with, which you might not know about, or you might know that it exists, but you don't have access to. And these sort of strings, although they might not work in all cases, they kind of cover a lot of cases when you put, especially if you're filling up a registration form, for example, you might have user input validation in the name and username, and maybe in some other areas. But the address, most of the times, has very little input validation because of all the weird names. And it might allow you to put these characters. And then, as an attacker, you have to watch the logs of your HTTP server and wait. And waiting is very boring. So it was an online casino the first time that I did this, and I didn't want to wait. I was tired, it was late, they were in a different time zone, and I decided to speed things up. And I passed a transaction with a credit card that had very little money on it, and then contacted their support complaining, asking, why is my card not working, and I should have credit, but I don't. Just like their customers. Actually, it was a foreign language with a different character set, so I had to use Google Translate, and But what I did was I sent it from the email address that I registered with their site, and as soon as they read my email, they looked me up, of course, and Mr. Joe Blogs had some funny HTML in there. as soon as they opened my account on their back office system, which I had no access to, I started seeing HTTP requests going to my web server. And these were my script tags being rendered on their web browser. So what my JavaScript did was it read the contents of the page, so it gets the DOM and it sends it through a POST request to my server, and also the cookies. And I did a demo of this. Of course, I couldn't use my client's website. That would get me arrested. But I have a sample web application. And this is the administrator, the support logging in, if they get the password correct. It's very realistic. And the support can see the users that are registered. Now I'm going to use a different web browser, and which represents the attacker. And the attacker then registers to the site, chooses his payload, in this case screenshot.js. And is registered. Now there is there doesn't have to be any cross-site scripting vulnerability in the front end. What's important is the backend. And in this case, the backend has the cross-site scripting in the name. So if you don't see the script tag showing up there, that means it's being rendered probably. And we can see the web browser activity using, just in this case, I'm using HTTP Fox, but you can use anything else. And it's sending a screenshot based on the HTML data of the page, and then using HTML5 support in the browser to render a PNG file. And then the attacker goes on his web server where he's storing this PNG file, and can see this image of the administrative area. So that's pretty cool, and it works on a lot of clients, as in they are convinced. Maybe they don't want to test, they don't want you to fully test it this time, but next time they're probably going to ask you as a pen tester to, properly test it. But sometimes screenshots are not enough, and there are various things that we can do with cross-site scripting. I like Beef. Beef has a lot of features. One of them is the tunneling proxy. And it's great for demos, especially if you have the administrator next to you and you're doing a live demo for them. Then Beef is ideal, because you can tell them, yeah, hey, log in and do this, and then you can use the tunneling proxy to use the administrator's web browser and show them that you are logged in through their web browser. And that's pretty cool, but it does require the attacker and the victim to be on the same time zone, so you need to be online and watching and seeing what's happening. So yeah, it's not, I mean, I like that, but in realistic attacks, I prefer to have something which works for one shot, and it works automatically for me without much user interaction. I like that better. And I thought one of the, so I had another case, and they were not using cookies, they were using basic authentication. Actually, they had a form-based, but I couldn't get the cookie, so I couldn't log in using their session. So one of the demo that I'm going to show now is how you can use the administrator's logged in web browser to first log out, then get the login page and display it to them while grabbing their username and password. So we have the attacker, and this time in the name, the attacker uses formgrabber.js instead of screenshot.js. Realistic. So the victim administrator, he can be logged in already and just refreshes the page, or logs in and is immediately sort of logged out. And the web page is still on the same page. So what's happening here is the web browser of the victim has searched for the login script, logout location, logs out, then gets the the login page, the contents of the login page, appends JavaScript to that to hook up the form, and then as soon as the victim types in the username and password, that JavaScript sends the username and password to the attacker instead of the victim. And I think that's pretty cool, especially if you want to keep access and test their hidden web application correctly. If you can get to that, then it's great to have their credentials, of course. Also, you can get an idea of what their passwords are like, because most of the times they have patterns and they use the same password for everything else. So passwords have a lot of value for the penetration tester. One more, the one-shot backdoor. Yeah, so what I showed before with WordPress was mostly I showed how to add an administrator, but you can do a lot more than that. And if you add an administrator, that's not exactly stealthy. I mean, the administrator might look at the list of users and notice, hey, there's another admin. I should be the only one. So he might or she might get jealous. Apart from that, WordPress installations, especially for companies that are security conscious, so these companies are more likely to do a penetration test anyway, they're probably going to block access for WP admin, except for their IP net block for their office. So you as a penetration tester are not going to be able to access that location, most likely. So even if you got their username and password, even if you created a new user, it's useless for you as a penetration tester. So, and besides, by default, WordPress sends emails nowadays to the administrator telling him, hey, a new admin has been created. So that's not very stealthy. So I thought, well, themes in, I thought how shall I, there's various things that you can do, but my favorite one is to backdoor 404.php, because themes in WordPress are not just static HTML, but they are very flexible. They are PHP and style sheets, of course, which means that the theme editor, since it edits themes, and themes are made out of PHP scripts, it edits PHP scripts. And I think since 404 templates are not usually accessed except by mistake, I thought it's great to backdoor that. So let's look at a demo of this payload that backdoors the 404 page and how to then access it. So we have the attacker's website, and in this case I'm using HTML5 course, which happens to be too permissive. But you can use cross-site scripting, you can use other vulnerabilities for this demo. So the administrator is logged in and is going to try to win an iPad, because iPads are usually free. So if he clicks on the link, there's something happening in the background. And in this case, it's very similar to the cross-domain.xml thing, but it's using cross-XHR requests. And what it did was, it told the administrator's web browser to first find out the 404.php link, because each team has a different URL. So first you have to get that URL to make sure that you backdoor that team, and then reads the current PHP code, sees if there's a backdoor installed already. If there is not, it appends its own backdoor. So, and then as an attacker, once that worked, you go to the 404, which has a nice new password, which hopefully no one notices, but you can obviously hide it. This is just for the demo. Password is 1. Of course, you have to set a very weak password for your clients. Just kidding. And in this case, I'm making use of a PHP shell, that you might find on WordPress or Joomla that has been hacked. So it's a very realistic attack, and this gives you access to their systems, to their underlying systems. This sort of script is used in the wild, so it's used by not just penetration testers. In fact, I think it's more used by hackers from Romania and Russia than real pen testers. But I wanted to show something that has at least the same sort of style of the real attackers that we're trying to simulate. So most of the issues that I showed are kind of features of HTML, features of JavaScript, features of Flash. They are not necessarily bugs in WordPress, for example. In fact, I didn't show anything that is not a feature in WordPress. The HTML uploading of HTML files is a feature for them. But you can use the same payloads across these different kind of exploitation scenarios. Same payloads for different methods. And so there's various things that we can support with the same payloads. And cross-site scripting, of course. Stored, reflected, client-side, I showed quite a few of them. Cross-domain policies, I support HTML5 and Flash. No Silverlight yet, and I didn't really test many sites with Silverlight yet, apart from one. So yeah, but if there's some jQuery plugin that we can just put there, that would make it easier to support Silverlight. And what's cool about this is that you can show to your clients that the web application that you're testing that you're penetrating, that you're intruding on, doesn't necessarily have to be vulnerable itself. But as long as it's your client and as long as it's in scope, then you can attack it through some other web application on the same domain. So these are the sort of payloads that I've implemented. Not many, but there's a lot of place for adding more. Some of the things that I'd like to add is support for Outlook Web Access, for Exchange, where you can, for example, if you find some sort of cross-site scripting vulnerability, either in OWA or, say, in some other web application on the same Exchange server, then you can exploit that to, say, force the administrator's web browser to create a filter rule that forwards all emails that have password in their body to your attacker email address, and then every email that he gets is checked against this rule, and you get all their passwords, because admins like to send passwords by email anyway. I seem to have attacked a lot of admins. Changing the email address if you have an online forum or some sort of social networking site, it's going to always ask for the email address and send, and if you want to reset the password, send a new password to that email address. So as a penetration tester, if you happen to find a security issue there in that web application or in that domain, then you can force the victim to have their email address changed to yours, and then you just reset their password and gain access to their account. And this has been done a lot in the past 2 years publicly by hackers from Anonymous and so on. So it's something that's being done, and we as pen testers we should show this as well, not just read about it in the news. And the generic payloads, I'd like to add more generic stuff. I think there's a lot of things that can be replicated across different web applications. Maybe a lot of web applications that I test are not publicly available, unlike WordPress or a lot of other open source tools, web apps. So it would be cool to have more generic stuff, and tools like Beef, they do a lot of generic stuff. So there's a lot more, and I've discussed with Michaela integrating with Beef as well before, and we will probably do something in that area. But for now, I've created a simple tool, Gen Payload or Gen Payload, and this creates your payloads according to your requirements, according to your variables. So it can create payloads for cross-site scripting and for Flash, for Adobe Flash cross-domain exploitation, and HTML5 course. And yeah, we can add more output types as well. So I can, oh yeah, and you can chain payloads. So you can, if it's a one-shot cross-site scripting, say, like the blind cross-site scripting vulnerabilities that I've exploited, you might only be given one chance, because maybe they somehow, most of the times they don't even realize at all, but maybe they somehow realize that they've been attacked, or they think that something is fishy. They might not realize that it's a cross-site scripting, but they would be more cautious on which emails or which support requests they open up. So chaining of payloads is very useful. First you take a screenshot, for example, then you get their login page and get their passwords, and then you do something else, and then you, at one shot, and that's pretty cool. Let me show you how it looks. Maybe some of you would be interested in joining the effort. How's it looking? Can you see it? Yeah. So yeah, you can list. You'd usually list the payloads first. So, and then you can choose the payload. And if you just press enter, it will use the defaults, which might not necessarily work for you. But if you press enter, it will just output to standard output to redirect to a file, test.js, and that's it. And then you can pass it. In this case, I only have one parameter, but you can, of course, different payloads have different parameters. So in this case, you can pass it the parameter dump URL where it uploads the file, and it would generate the payload. Like that. And the payload looks like this. So this is the JavaScript payload, which is just one file which contains everything. The variables I put on the top might change later, but you have the variables there, and if you go to the bottom, then you get your payload over there. So the payload is really simple thanks to all the hard work done by the plugin jQuery plugin developers, and that's one cool thing about using plugins for jQuery. And then you can generate different types of payloads. You can choose across JS, SWF. So let's do an SWF file. And now it created a directory with all the files you need. It included FLXHR, which is an interface for which mimics XHR, but uses Flash instead. So this is great for us when we want to exploit cross-domain.xml, an insecure one. And then you have index, which calls all these scripts, and it calls the jQuery plugin for FLXHR. And you can see that the payload, I'm not gonna cut that. You can see that the payload is almost the same as the payload. Oops. As the payload that we created for JavaScript. So it makes things much simpler. Let's see which other options we can choose. So different types of payloads, parameters. Yeah, I think that's it for now from that point of view. And this is the sort of file structure that you get. So in bin, you get gen payload, and yeah. And then in src, you have a general configuration where you can specify the status URL, which is a URL where you can send notifications to the attacker. It doesn't have to be specified if you don't feel like it. But it's good to know if the exploit worked or not and where it failed. So it sends some sort of debugging information to the attacker. Then you have includes, where all the things that are kind of static that will never change, like jQuery and all those plugins, I would put them there. And the payloads is the one that is interesting for us, which contains usually just two files, always a config.ini, which specifies everything else. So you can put your parameters there if you want to kind of hard code them there, or you can pass them through the command line using the -P argument. And then you have the payload itself. And some payloads, like the WordPress backdoor, they make use of external code, which is read from here. So you can specify, by default I provide backdoor that is a no-brainer, just using pass-through. But you can also use other PHP backdoors, and like this one, web shell by orb, which is the one in the video demo, which is not included. And there are various payloads, I mean various PHP shells that you can make use of and maybe adapt. They might not work for 404, so it depends on, but if you upload a PHP file, then you can specify which PHP file you want to upload as an attacker. So that's the sort of structure that I have. I hope maybe some of you could want to submit their own payloads when they are working on some CTF or some pen test. Oh yeah, solutions. Well, in security, I guess you guys know it. There's no one solution that solves all your problems. I mean, yeah, there are, but that's just what the vendors tell you. But in reality, antivirus doesn't solve all your problems, or web application firewall would not block many of these security issues that I showed here, and so on. So it depends. However, there are some things that you can always do, and it will reduce your risk. For example, in the case of Gmail, what they do is they allow you to upload attachments and view attachments, but they store these, they show you these attachments on a separate domain name. So you view your mail, your normal mail, on mail.google.com, but they show you the attachments on a separate domain name. And if things work well in the web browser security scenario, which they might not, but if they do work well, if SOP works as it should, then it doesn't, you can mitigate a lot of problems like that. And in the case of the WordPress blog, if your authors are gonna start stay using weak passwords, that's really bad, of course, but you can always mitigate, you can reduce the risk of the HTML file upload by putting the uploaded files in a separate location, which is not accessible through the same domain name. Doesn't mean that that solves all the problems, of course, but it does help mitigate. And of course, cross-domain policies, they should never have asterisk in there. Asterisk and security, they don't go very well when it comes together on the same sentence when it comes to cross-domain. So yeah, please test my code, play around with it, submit bug reports, fork on GitHub, and say goodbye to the alert box. There's no need for that anymore, I hope. Some references, there's a lot of work done by other people, all good stuff. So I tried to include the ones that I know about, but yeah. So questions, answers, and that's the URL of the project.
Yeah, thank you very much.